welcome to Space Store Live.
Once again, welcome to Space Store Live.
My name is Remco Timmermans. We are going to literally the middle of nowhere. We're going to...
My name is Andy Torbett. The thing I do most often is I'm a diver and an underwater explorer.
The Interplanetary Podcast, our mission is to put the ace back into space.
And tonight with us we have Nick Howes and Terry Moseley, and we're going to be talking about Mars exploration.
The last time Terry and I were together, we were in the front of a telescope.
This week, we are focusing on satellite. Today, we are going to be building a model of the Hubble Space Telescope. This week, we are focusing on learning more about the solar system.
Cool. A very warm welcome to everyone joining us here on Zoom. A big welcome to Aidan, Declan, Gary, Peter, and Peter. And also a very warm welcome to if you're joining us on YouTube. This is our second Space Store Live Roundup with Nick Howes and Terry Moseley. How are you guys doing?
We're pretty good. I'm pretty good. Yeah. How are you, Terry?
Good, well, yeah. Getting used to it.
Awesome. So this is where we bring you the latest and greatest of space news. So I'm going to let you guys take it away and hope you guys enjoy the ride.
Cool. Hello, everyone. It's been an interesting few weeks in space since we last did this. So I think Terry will probably agree. Obviously,
absolutely.
the big news.
The seat stuff.
Yeah, the big news, I guess, over the last 2 weeks has been the huge success of SpaceX. At the second attempt, the first attempt, obviously, they had a very almost last-minute launch abort due to some range safety issues. Obviously, with the weather, they've got to be really careful in terms of when you can launch a rocket. The second one, the thing that grabbed me, Terry, I don't know if it grabbed you as well, watching it from the in-cockpit view, two things really hit me. One was just how smooth the ride was. It was incredible. If you look at, you watch the movie First Man and the Gemini launch with Dave Scott and Neil Armstrong portrayed in that, and how the spacecraft is literally shaking the astronauts to pieces. And you think, this is what spaceflight should be. And you're watching like Doug and Bob going up on the SpaceX mission, and it was almost like they were riding a bus.
Yeah, it was even better. In fact, if you hadn't known that they had launched, you would have thought they were still sitting on the launch pad. It was that smooth. And my initial fear was when I saw the touch screen, was I was afraid that if the vibration was as bad as it was in some of the previous launches of Gemini and Apollo, that you couldn't touch the right button on the screen because of the vibration. But they evidently had worked out that it was going to be excitingly smooth. They probably knew from internal video on the Crew Dragon, the Cargo Dragon launch, which is basically the same spacecraft but taking up cargo, that there wasn't all that much vibration. And it really was just, as you say, like being on a bus on a very smooth road.
It's interesting as well, the analogies. A lot of people made the kind of analogy between some of the scenes from 2001 and the way that the spacecraft looked in that, and the interior look of Dragon. But again, going back to the touchscreen one, though, it's interesting in that obviously with a low Earth orbit launch or a launch where you're basically just going up to the ISS, ground control can have command override really easily and really quickly. So if something were to go wrong, they could basically take control. And it was a pretty much autonomous mission anyway. They didn't really need to touch much in the way of control. I fear for the longer duration space flights beyond the moon, up to the moon, you're going to be okay. It's a couple of seconds maximum in terms of being able to send up a command to override whatever. If you're going on to Mars, you could be looking at 10, 15 plus minutes round trip time, where if something were to go wrong, if you had one of those going back to first man, the whole thing with Neil Armstrong and Dave Scott and Gemini when the spacecraft undocked from the Agena, was docking with the Agena, and it went out of control into this like almost 1 or 2 cycle per second spin. If that were to happen on a real mission heading out towards Mars and you've got touchscreens all over the place, it'd be very interesting to see how that was dealt with. There's going to be obviously manual switches and joysticks, but that'd be something I'd really want to be factoring in, and I guess they are. But.
Yeah, I agree with that. In fact, you could be dealing with double that amount of time for round trip signal. In other words, a problem coming back to Earth from the spacecraft, and then them deciding what to do, and then sending the signal back to the spacecraft. So you've got maybe up to 30 or 40 minutes delay if you're approaching Mars. So it could be a very serious issue. But I would say the only times when it's really likely to be a problem are on what they would either be leaving Earth orbit for Mars or leaving lunar orbit for Mars. Once you're coasting on your way to Mars, there's not all that much that you need to do, maybe minor mid-course correction. When you approach Mars, then you're going to have to slow down and initiate the landing sequence. That's when it could get hairy.
Yeah, that's the issue when you're going into Mars orbit and you're using, either aerobraking or skipping or whatever they're using to decelerate the spacecraft. Yeah, it's going to prove to be really interesting. But so far, a touch wood here, incredibly successful mission. Another big notch in Elon Musk's bedpost when it comes to delivering what he's promised on. Obviously, he's still working very hard towards Starship and Boca Chica. There's all sorts of different Starship incarnations being rolled out almost on a weekly basis now, and people are getting really excited about that as the kind of future. On the flip side of Elon Musk, we shouldn't really forget the fact that he's still launching the thing that we're affectionately terming space vermin. These vast collections of Starlink satellites. The latest batch, they're saying they're going to integrate the sunshades in, they're going to reduce the albedo, they're going to reduce the magnitude. My fear with this is that if our listeners aren't aware, basically the naked eye, as it were, the human eye, can see down to about magnitude 6 in a really good dark sky location. So if you go out into places like Northumberland or Mid Wales or the South Downs or Wiltshire, those kind of places, you can get a really good dark night where there's no moon. You could probably see objects to about magnitude 6, and it's a logarithmic scale. The Hubble Space Telescope can see to about magnitude 25, 26, etc. Beyond mag 6, it's really difficult to see anything. Now, if he reduces the reflectivity of the satellites and drops them to, say, mag 7, as far as the public are concerned, there's no more problem. But for astronomers, it's a huge issue. Yeah,
they'll be getting trails across all their exposures, interference with all sorts of observations, basically not just visual, but taking spectra and so on. And one of these, or a couple of these satellites cross the field of view, it just ruins that particular observation. The thing about Musk is he's not interested in astronomy as such. He's purely interested in space, Moon and Mars, basically in the longer term. I'm not sure if he was even aware of the problem he was causing. But you and I, having an astronomical interest as well as a space interest, are very much concerned about this.
Well, there's that, and there's also the issue of spectrum and radio frequencies and radio astronomers. It's not just optical astronomy. Radio astronomers are going to have a really hard time with these as well, because they're going to be dominating a lot of the frequency spectrum. Obviously, there's a lot of satellite inter-satellite communication and uplink downlink communication, and you've got telescopes like the Square Kilometre Array, which is based in South Africa and Australia, which is going to have a really hard time with this. They've got a big enough problem trying to filter out everything that they're trying to filter out anyway, with one of the most sensitive instruments ever designed.
Yeah.
So it's going to be, I would say, a very, very challenging few years. Something did cross my mind today, though. Elon Musk has got all these massive contracts with the United States government now, and he's obviously, delivered on his promise to be able to send US astronauts back to orbit from US soil with the Dragon capsule. He's beaten Boeing, he's beaten everybody else. Is anyone in the US government going to turn around and say, you can't do this? He has got such a stranglehold now.
Yeah, I don't think it's the power to tell him not to do it. I mean, you or I, if we had the technology, could do it, and nobody can stop us. What I'm worried about is that other people as well may join in and launch their own fleets of communication satellites, because he's not the only one interested in this. So it is going to be a problem, and possibly the only long-term solution is to have a lot of instruments in space above the orbits of the satellites or on the moon. Certainly I can see in 50 years or so, the Earth is going to be totally surrounded with fleets and fleets, hundreds of thousands of satellites.
The cost of that, though, is absolutely extortionate. You only have to look at the Hubble Space Telescope. The servicing mission for that was $450 million. You could have built and launched another Hubble for less. I mean, that was always the quote. You think about putting something on the moon, and the cost of just getting to the moon with anything sizable at the moment, you're into the billions. Whereas you could put up a new optical telescope somewhere, in Hawaii or some remote place in Paranal for a fraction of that kind of cost. And then the instrument is constantly updatable. You only have to look at the Palomar Observatory, the Hale telescope, which is dating back almost 100 years now, and it's still functionally one of the most powerful telescopes on Earth because of the Palm interface that they introduced on it with its adaptive optics system and the spectrographs. You can continually update these instruments, whereas you look at the James Webb. If the James Webb fails, that's $10 billion down the drain.
And it's not flexible.
It's going to be interesting times, which kind of leads on again. It's not just the astronomy problem that we're dealing with here. Anyone who's seen the movie Gravity will know what the Kessler syndrome is, although you may not know what the name is. So around about 40 years ago, a scientist by the name of Kessler, hence why it's called the Kessler syndrome, theorized that at some stage in the future, space, low Earth orbit, medium Earth orbit, geostationary orbit, whatever, is going to become so crowded that you're going to have an uncontrolled basically knock-on effect of debris, and there's already millions of pieces of debris up there, ranging from like a fraction of a millimeter across up to the size of a bus with the Envisat satellite, which is now defunct. So you've got millions of pieces up there already which are colliding already. I mean, not on the frequencies that everybody's afraid of, but this is only going to get worse if Musk launches 10, 20, 30,000 satellites, and then there's, as you said, Terry, the Russians, the Chinese, all these other organizations say, well,
India
he's
too.
done it, we'll do it. We'll do it. It's going to be bad.
It's one of the possible explanations why, with apologies to anybody who believes that I'm wrong in this, we haven't had extraterrestrial visitors. Some of the other civilizations may have made their own planet so dangerous to escape from that they simply are not sending any live crews up anymore. But that's just one theory. That's one of my little pet ideas.
It's a good one. I mean, it's interesting that we tend to be, as a planet, as a species, very reactive. Our governments are very reactive. They don't, I mean, the current COVID pandemic, there were all sorts of talks and discussions from the likes of Bill Gates, President Obama saying years ago that we need to factor this in. We had SARS, we had MERS, there's all sorts of things, almost like pre-warnings. And it's only now that it's happening that everybody's really saying we've got to do something about this, and shut down whatever's caused it, develop vaccines, etc. Now, to me, the only thing that's going to stop this happening, and it will be a tragedy, is somebody is going to die. There'll be a commercial launch, there'll be a tourist launch, there'll be something will happen, and a piece of debris will hit it. It could even hit the ISS. And the ISS is already having to do multiple orbital maneuvers a year to dodge out pieces of debris that are flying at it. And you only need something, about the size of, I don't know, a desk to hit the ISS, and that's no more ISS. It's gone. And those kind of size pieces of debris are up there and are getting, sadly, with the failure rates on satellites, and Musk himself has said they've got a 5% failure rate at the moment. If you put 20,000 satellites up at a 5% failure rate, do the math. You're going to be increasing the number of defunct satellites in orbit by almost the same amount that's up there already. So
it's
yeah,
exponential. It's sort of, to quote a current term, the R rate, if you like, the number of times that one satellite will break up and produce maybe 1,000 bits of debris, and those 1,000 then affect another 1,000, and so on. It can become a runaway effect, and that is actually what the Kessler syndrome is, basically. But once it's started, it's almost impossible to stop. How do you collect these tiny little bits of space debris? There are some ideas in hand and some one or two little projects underway, but they're only scratching the surface of the problem.
It's not even that. I mean, you look at Astroscale, have got some really great ideas for deorbiting larger satellites. You've had Northrop Grumman recently with their MEV mission, where they've been able to dock with a satellite that was defunct and basically give it a new lease of life. But as you said, there's millions and millions of pieces up there. And unlike, say, plastic in the oceans is drifting at a few knots. And it's a substantial problem, but it's a problem that humanity could solve. You can't solve this traveling at 9 kilometers per second.
Yeah.
There is nothing we currently have that can solve this problem. So it's a really big one, I'd say. Right. Sorry, Ted, go on.
No, I was just going to say some of the pieces are too small to track. The American military are tracking everything above a certain size. I can quote you exactly what it is.
It's about 5 to 10 centimeters now.
Yeah, something the size of an 8mm nut floating around will go straight through the ISS, and if it hits an astronaut, that's the astronaut gone
game
too.
over. Yeah,
but that's too small to track at the moment. Anyway, I interrupted you there. Sorry.
No, you only have to look at how it's exponentially grown. Obviously, 1957 was the first time we put something up in space into orbit anyway with Sputnik, and it's just kind of grown and grown and grown. And now with commercial launch and launch being so cheap relative to how it was, I mean, there's quotes of between $20,000-$30,000 per kilogram to get stuff into orbit with some of these commercial launch companies. It's anyone can do it practically. A university, a school can even put up a satellite.
Yeah.
And thankfully, these low Earth orbit CubeSats, they're only designed to survive for a few weeks, but it's the larger stuff that's going into higher orbits. And then you've got the likes of the Indian ASAT test, which happened last year, which blew thousands of pieces of extra debris in there by trying to shoot down a satellite. And the Chinese have done this before, and the Americans have done it before. So this is the next big problem. And like COVID, all I'd like to say publicly is please listen, because it's going to happen. It's not when, it's not if, it's when. It's going to happen. It will happen. People ignore that with COVID. They've ignored it with mass pandemics. It's going to happen. Anyway, moving on to a slightly brighter topic. Coming up on June 20th, 21st this year, is the summer solstice, which is a nightmare for astronomers because it basically means we get almost no dark sky in the evening at all. But there's some really exciting events happening around this time, isn't there, Terry?
Yeah, of course, it's only our summer solstice. If you're down in Chile or New Zealand or Australia, it's the longest nights of the year. Yeah, just by coincidence this year, maybe just say first, it's simply the solstice literally means the sun standing still, which it doesn't. What happens is it stops passing further north in the sky as it travels in its yearly path around the ecliptic, and then after the solstice it's starting to move south again. But for us in the northern hemisphere, that gives us our longest day. By coincidence, this year on the 20th, we have a very nice annular eclipse of the sun, but unfortunately not visible anywhere in the UK. The track starts in Central Africa, goes across Ethiopia, then I think Pakistan, India, and China. So anybody along there is going to see a very beautiful and interesting, fascinating event, not as spectacular or as mind-blowing as a total eclipse, but even so, it's a very interesting thing to see. Unfortunately, in the UK or Ireland, we won't even see a partial eclipse, but there are other ones coming up in the future.
It's one of those great things, though, much like the SpaceX launch, obviously with the whole world practically in lockdown now, traveling over to Tanzania or Central Africa, etc., to see this is not really going to be an option. But there's so many webcams and so many live streams that are going to be happening all around the world. And people like Fred Espenak, who's a famous eclipse chaser, will doubtlessly be out there, and various other people doing some of the science on this. So it's well worth watching. The difference between the annular eclipses and the total eclipses, obviously the distance between the Earth and the moon varies over the course of the year. And at some points, obviously, the moon pretty much exactly overlays the sun. There's a 400 times difference between the distance between the Earth and the moon and the Earth and the sun. So you get a total block out, and that's when you can look at the sun safely. It's the only time you can look at the sun safely, and you can see the wonderful prominences and the corona around it. With an annular eclipse, what you get is this kind of ring of fire, this beautiful. I've seen one in Spain a few years ago, and it was really spectacular. It's almost as haunting as a total eclipse, but because you. Oh well, no, I was in China. I was in China, and it was like 6 minutes. Amazing.
You have seen a total one successfully, I presume.
Yeah. Well, we were in Hangzhou in China, so it's practically the only place I think in the entire track that got to see it, because I know Shanghai was totally clouded out, and I remember going back to the hotel after taking like 6 minutes of images of the eclipse, and all the astronomers in the hotel back in Shanghai just looking in complete disgust that I'd managed to get this image.
They probably still drag their hair.
It was a particularly wet one.
Now they are quite rare. Sorry, annular eclipses actually occur slightly more frequently than total ones, but to see it as annular or total, you have to be in the right place. You have to be right on the track. The next one that is visible in the UK is actually not till 2081, and that's visible only in the Channel Islands. And the next total eclipse visible anywhere in the British Isles is not till 2090, so they're quite rare. And in fact, you have to wait till 2093 before we'll see an annular in the UK. So they are very rare events in any one place, but taking the Earth as a whole, you get 4 or 5 every decade of total or annular eclipses.
It's one of those things it's worth travelling to see, because anyone who remembers, the debacle in the UK, the last one in the late 90s, where they were trying to do outside broadcasts from Cornwall, and it was just sadly really clouded out, but people in the channel on ships were seeing it really clearly. Brings us on nicely to the fact that the sun is picking up a little bit as well. I've been imaging in H alpha and calcium K line recently, getting back into that, and because the sun's been pretty much dead for years now in terms of sunspot activity. It's almost like a Maunder minimum when we had the last one in about 500 years ago, and frost fairs on the Thames, etc. So it's not quite that bad, but almost no sunspot activity for quite some time now.
Yeah, it's an 11-year cycle, and we're just apparently gone through a very deep minimum. Still very, very little activity. Now, the sun, of course, to everybody out in the open, the sun looks perfectly normal. What we're talking about is the number of sunspots and other activity on the surface, like flares and coronal mass ejections, which are of particular interest to solar astronomers. And the 11-year cycle is not so much the total output of energy from the sun, but these particular phenomena. And they have been very, very low for the last couple of months, year or two even, but it now seems that the new cycle has started. The reason we know it's a new cycle is the magnetic polarity has changed, and that's getting a bit technical, but basically this latest event does indicate that the new cycle has started. It's not an old thing happening from the last cycle.
And what's terrifying for anyone who's watching this as well as listening, the image that we've got on screen now, that big kind of explosion in the 1 o'clock position heading up towards the top right, is the distance from the Earth to the moon across. So that gives you an idea of the kind of scale. If these things head our way and we get major events, again, that could be extremely disruptive to the Earth. And again, given how many satellites we're going to have in orbit, if we get what's called an X-class flare, which is one of the biggest solar storms you can get, or what's known as a Carrington event, which happened in the mid-1800s, and at the time there was almost no electrical devices, but the Morse code telegraph transmitters were kind of going nuts when this happened. If we get something of that scale happening in the next few years, when we've got all these satellites in orbit, then you're going to have an even bigger problem, because you could take out thousands of satellites with one of these. Yeah,
you wouldn't be able to rely on your GPS for quite a while.
Yeah, indeed.
Yeah, and more serious effects, but that's just sort of a little aside.
Well, yeah, the electrical grid, Canada, the last big one, took out half of Canada's electrical system. So that brings us on nicely. Just very briefly, some updated news in terms of what's happening with the UK launch. So obviously with COVID, the UK's launch aspirations have kind of been put on hold a little bit and set back due to government obviously not sitting and clearly focusing on things that are vastly more important. Some recent studies have come out there that show the Shetland sites. So there's various sites that are vying for UK launch. There's about 5 up in Scotland. Prestwick, which is horizontal launch proposal for a kind of aircraft takeoff, very similar to what's happening now in Cornwall, at Spaceport Cornwall with Newquay, where they're tied in with Virgin Orbital, and they're going to be developing their launch system using a kind of refactored 747, dropping a 21-meter rocket from underneath one of its wings. That will then basically launch and go up to orbit. They did a test recently. It failed, but that's what happens with space. Vertical launch is quite interesting because you've got companies like Skyroarer, who recently had a very successful static fire test up in Scotland. That was really good to see that happening. The key issue you've got with a lot of these launch sites is going back to what we were talking about with SpaceX at the beginning, is range safety. So if you've got a rocket taking off, basically heading northwards, because a lot of these proposals for Scotland are going to be putting satellites into what's called a sun synchronous or polar orbit. So they're essentially going to be going over the poles and let the Earth's rotation go underneath them. The key issue you've got there is that the launch sites, most of them go directly over the oil fields in the North Sea and over the Faroe Islands. The Shetland one and Western Isles, I think there's slightly better objectives for them. Sutherland is the one that everyone's kind of keeping an eye on at the moment, because there's been some studies just come out in the last few days talking about what's happening with Orbex and with Lockheed Martin, the main contractor who are behind that. And I just think this is a really fascinating time to be involved in space in the UK. But it's one that I think we'll talk about more in future shows, but it's one to keep an eye on this. It's going to happen in the next few years. We're all hoping that the UK's economy, it's one of the great drivers in the UK economy at the moment. Space exploration, etc., employs thousands of people across the UK. There's places like Harwell and the Goon-Hilly ground station and various other space clusters, especially up in Scotland, that have got amazing production and engineering facilities, and British scientists have been involved for decades in a lot of the missions. The James Webb Space Telescope's principal instrument, the MIRI, has been designed in the UK. So I think this is going to be a really interesting thing to kind of keep an eye on.
Yep.
Moving on from that to our final topic, and this is one I know that's close to both Terry and my heart, is Asteroid Day, which is coming up.
Yep, June the 30th, the date in which the largest recorded impact with the Earth occurred in 1908 in Tunguska in Russia, where something hit the Earth. We don't know exactly what, and that's the fascinating thing about it, but it produced an impact which is estimated between 9 and 30 megatons, which is multiple times bigger than any of the bombs that fell in Hiroshima or Nagasaki, about the size of the biggest nuclear bomb that was ever detonated. That was by the Russians. Now, this was right in the middle of very, very remote uninhabited Siberia. There are some reports that some people died, not confirmed. There are definitely reports of people being injured. And one of the fascinating things about that is if you take the location where it landed, if it had hit the Earth 5 hours earlier, it would have obliterated St. Petersburg, Leningrad. It's just pure chance that it was in an uninhabited area of Siberia. So 30th of June every year now, for the last couple of years, we have been celebrating, perhaps not celebrating, taking note of the fact that these things do.
Raising awareness.
Yeah. And what can we do about it? And that's the subject for maybe another discussion some other day. First of all, you have to detect the thing that's heading towards the Earth, and then you decide if you can do anything to stop it. And if there's no time or not the technology to stop it, you need to evacuate the area where it's going to impact.
There's been a lot of modeling done on this. It is very interesting because you only have to look at what happened 65 million years ago. And obviously, we've had mass extinction events all through the Earth's history. But obviously, 65 million years ago, something hit the Yucatan Peninsula, several kilometers wide, wiped out 80-90% of all life on this planet. Dinosaurs have been quite happily taken away for hundreds of millions of years. It is a major threat, and it's like the SpaceX Starlink / Kessler syndrome issue, in that if we have no way in the coming years to be able to launch something to stop this, and that's the big problem. We will need to be able to launch something to stop it. We don't have anything right now. There's all sorts of talk about paintballing and the Orps effect, where you can change the albedo of an object and change its spin and change its orbit. There's that. There's hitting it with nukes. We don't have the nukes that can do this. If you've got something the size of Manhattan approaching the Earth at potentially up to 100,000 miles an hour, a nuclear device is going to tickle it. At the very best, you're going to turn a bullet into a shotgun, and you're going to have, is exactly what happened in the movie Deep Impact, which the science was actually quite good in that. 75% of the Earth is covered in water, so if it hits the ocean, you're going to have gigantic tsunami, potentially 1,000 feet high, traveling at 1,000 miles an hour. So it's something we have to do. And as I said, if we populate our low Earth orbit with enough debris that we can't launch anything, then it's literally just a waiting game again, because one day it may not be an asteroid. NASA have got a really good hold on most of the asteroids now, Earth crossing ones, the Apollos, etc., where we basically, I think it's about 95 to 96% of all asteroids above 1 kilometer in size have been catalogued. That to me has never been the big problem. Obviously, it could be, you could get a bumped asteroid coming in from the outer solar system that kind of comes in on a Korean collision pathway with us. To me, the big problem is comets. The big problem's always been comets. If you look at Hale-Bopp in 1997, that thing was 35 kilometers wide. The nucleus of that comet was traveling, at its closest approach to the sun at anywhere up to 100,000 miles an hour. If you've got something 35 kilometers wide hitting the Earth at 100,000 miles an hour, you have nothing left. You have cockroaches and Keith Richards. They're the only two things that are going to survive. There's nothing left. So we need to do something about this, not just talk about modeling, not just talk about it at United Nations level, not just talk about theoretical ideas. We need to start planning for this. And I know there's various missions. The European Space Agency are looking at a mission where they're going to try and look at impacting a small asteroid and see what the deflection is. There are all sorts of missions in the past. The epoxy mission was a kind of follow-on from the Deep Impact, where they, slammed something about the size of a coffee table into a comet just to see what happened. There needs to be more action, and we need something huge to get around this problem. It's something kind of the scale of a Saturn V. If you could put those kind of engines onto a comet or an asteroid at sufficient distance, then potentially you could divert it. But you only have to look at, what happened with the Rosetta mission and Philae, how complex it is to land. We're not talking Bruce Willis here. We're talking about something that's really complex to do, to land on a moving object that's rotating, that has almost no gravity. So it's a good one to watch out for. If anyone in the audience isn't aware of it, Asteroid Day, there's all sorts of events all over the world. Brian May gets involved, lots and lots of celebrities get involved. It's a really big deal, and definitely one to watch out for.
Yeah, I totally agree with you. Most of the asteroids that are potentially, at risk for the Earth don't go any further out than the orbit of Jupiter. The big comets come in from way, way out in the outer reaches of the solar system on orbits that bring them in very quickly. And that doesn't give you time really to prepare to deflect them. So while we don't hear so much about comets, they are probably in the longer term the more serious risk.
Yeah, you only have to look at Shoemaker-Levy 9. That was a classic example of a comet that, basically got torn apart by Jupiter's gravity and then slammed into Jupiter. And you had 21 pockmarks on the upper gas layers of Jupiter that were the size of the Earth. So this is not an insignificant threat. Luckily, we have Jupiter, which is kind of the Dyson vacuum cleaner of the solar system, hoovering up a lot of stuff. But things get through. And one day something will get through. And from the time we detect it, as Terry was saying, to the time it potentially hits the Earth, you're looking at a matter of 9 to 12 months most of the time. It crosses the ice line at Jupiter, Saturn, 9-12 months before it's in our neck of the woods. So it's something we really need to factor in. Anyway, hope you've enjoyed the news so far. If anyone's got any questions, please put them in the chat. I'll hand back to Latch now.
Brilliant. Yeah, thanks so much. I mean, I don't really know how to end after I've constantly been imagining a comet crashing into the Earth. But
it's got enough problems as it is.
Just make sure you have your helmet on.
There's actually a question coming from Peter Household, who's asking about the Kessler syndrome, and he's just questioning whether there's no current law limiting launches so far, is there?
There isn't. No, the United Nations, there are kind of guidelines and standards. There's what's called the 25-year rule, which basically states that any new launch or any satellite being launched should be able to effectively come out of orbit or be decommissioned within a 25-year span. To my mind, that's ridiculous. It's too long. 25 years is just an insanely long length of time when you're talking about scientific missions. Obviously, the Hubble, there are some exceptions to that rule, but 25 years to me, for most communication satellites, most satellites up there, it's too long. It's, the technology moves on at such a pace that you really need to be thinking about replacing them. You also need to be thinking about actual deorbit strategies. So having the capability on your satellite to have it trackable, properly trackable. If something were to go wrong, if the satellite were to go defunct, if you've got transponders on it, which you have on ships with what they call AIS transponders, having that capability to really track them accurately. Because at the moment, we're relying on government, military organizations, amateur astronomers, even tracking satellites and giving updated positional information. And that forms what's called TLEs, two-line element data. They can be out by kilometers. And the problem is that if you're traveling at 9 kilometers a second, being out by kilometers is useless because you can have collisions. There was one very near miss a few months ago now, between the IRAS satellite, the infrared astronomy satellite, and another satellite over North America. And it literally missed by a few meters. So when you're looking at those kind of speeds, you can't be playing guesswork. You've really got to know precisely where these things are. And the tracking, as Terry said, you can only track down to about 10 centimeters. So you've really got to think this one through. It needs global action. But then you've got rogue nation states, you've got North Korea, you've got China, who basically are just going to do whatever the heck they like, I would imagine. But then countering that, the United States, Elon Musk is doing whatever the heck he likes. The FCC have granted him a launch license, and regulatory oversights tick the box and say, yeah, you can launch 30,000 satellites. So it will only change when something happens. I'm convinced of this. Somebody is going to die, and it'll be an absolute tragedy when it happens, but that's the only thing that's going to force the hand of the governments of the world to say, right, we need to do something about this.
Yeah, I'd just like to say hello to Peter. I think he's somebody I know. The problem is not just what you do in the future. The big problem is what's already there, not just the number of satellites that are there, but the number of bits of satellites. And as we were saying earlier, that is going to increase exponentially. It's all very well have something the size of a refrigerator that you can track. When that breaks up into 100 pieces that are too small to track, that is when the problem really, really becomes serious. So certainly, by all means, let's try and control the problem in the future. But we have an existing problem at the moment, which at present we can't really do very much about.
If anyone wants to see the kind of what happens when this happens, obviously the movie Gravity was a good example. There's a lot wrong in that film, don't get me wrong, but the impact scenario was quite good. There was an impact just over a decade or so ago between Cosmos and an Iridium satellite, a Cosmos satellite and an Iridium satellite. If you go on YouTube and you Google Cosmos Iridium collision, you'll see what happened. There was loads of modeling done by a company called AGI who do some phenomenal software for orbital dynamics modeling. And they showed the collision impact effect and the spread of debris and how it just exponentially it doesn't grow. Obviously, the number of pieces is the number of pieces, but it kind of disperses and spreads out all over the planet. There was a really interesting experiment as well by the University of Florida where they built a satellite to spec, put it in a hypervelocity test chamber, surrounded it with foam padding, and then basically threw something at it at about 6 to 7 kilometers per second, about the size of a Coke can. That thing, they were still picking the pieces out of the foam a year later. They got to 180,000 pieces of debris before they stopped. So, that's one collision. If you had a cascading multiple, event collision scenario, you'd be looking at millions and millions and millions of pieces being created in a matter of minutes, hours, or days. So we have to do something about this. Yep. It's, and we're just two guys sat on a Zoom call. It really needs government level intervention here, and a serious government level intervention.
It's going to be the case that the only safe place to be is on the moon, not in orbit around the Earth. The further away you go from the Earth, the greater the volume of space, obviously. So once you're on your way to translunar injection, you're probably relatively safe.
If I was putting money into investments at the moment, I'd be investing in HAPS, which is high altitude pseudo satellites.
Yeah.
So high altitude balloons, drones, that type of thing. That's going to be the future, because if we can't observe from orbit, and this is the other thing, the knock-on effect of taking out the satellites is we can't do environmental modeling. We can't do all the things that we currently take for granted. You know, communications, it's not just losing Facebook and losing your Netflix and your TV and everything else that you may rely on from a satellite. It's environmental monitoring. It's all of the other systems, GPS. The defense of our planet relies, you know, for all nation states that have got armed forces on GPS or on some form of positioning system, be that the Chinese version, the Russian version, or the American version, or potentially soon the European version. But if that gets taken out, all that's gone. So this is why there's so much work and money being put into quantum navigation and quantum technologies at the moment for ground-based positional accuracy, because we may not have it in the future. Any more questions?
Yeah, I mean,
So go ahead, Terry.
Right, I was just going to say another unpredictable factor is the Earth's atmosphere, which varies with the amount of solar activity. The Earth's atmosphere expands and contracts slightly, and when it's expanding, obviously it's going to be slowing down the satellites that are just skimming above it, and that makes even the orbits of the satellites that we know and the big pieces of debris that we know about are unpredictable in the longer term.
Well, that's the thing. It's this nominal line, the Kármán line, which is this nominal line of where space begins and the Earth's atmosphere ends, but that's not where it actually ends and begins. Yeah. There's still atmosphere up, you know, hundreds of kilometers above that. Yeah. Obviously very tenuous, very thin, but it does have an impact on the satellites. They do get dragged down. If you put them into a low enough orbit, they will eventually get dragged down. And if you increase the atmospheric density and the atmospheric size, due to solar activity, you know, the expansion of the atmosphere, it's going to have an impact.
Yeah.
So,
sorry, was there another question?
Any more questions?
There is a couple more questions from Peter. He's just asking if you can mention the HAPS thing again.
So high altitude pseudo satellites. This is technologies that are now being developed where you've got very, very high altitude airships, which are solar powered, which can do things like Earth observation, obviously from a lower altitude than a satellite. You're only looking at 10, 20, 30 kilometers up. But essentially, they can give you a semblance of ground coverage and the ability to do communications, search and rescue. Some of the things that we use for satellites, things like flood monitoring, environmental monitoring, you know, things like deforestation in the Amazon, that type of stuff is going to be really, really important. At the moment, we rely on satellites and overflight satellites using synthetic aperture radar, which can see through clouds, etc. But if you've got a high altitude pseudo satellite, then it can stay up there pretty much indefinitely. You can bring it down as well. That's the other good thing with a HAP system. If it's like essentially just a big airship at really high altitude or a balloon at really high altitude that you've got some semblance of control over, then when you run out of whatever or your scientific instruments need updating, you can bring it back down again. And you know, all is well. You can't do that with a satellite unless you're the US government and you've got the X-37B, which is their top secret space shuttle that nobody's supposed to know where it is, but every amateur astronomer's imaging most nights, which is quite fun. You can't really do anything. You can't really bring it down. So HAPS, high altitude pseudo satellites, it's a big thing. There's teams in Australia that are working on this quite extensively at the moment. It's US teams. It's a big thing. It's a big area, and I think it's one worth looking at.
The other thing about that is, even though you're so high up, you still have a fair bit of atmosphere above you. So a lot of the space debris will actually burn up before it would hit one of those high altitude balloons or a big Zeppelin type thing. So they're not as much at risk.
Yep.
Great, yeah. Well, I think we are slightly overboard with the time. I think we should wrap it up here. Again, a big thank you to you, Nick and Terry, for such another wonderful talk. And so, it's been so informative and interesting, even though I've been constantly imagining a comet being hit from smashing into the Earth, and just space debris scattering everywhere. I hope that the audience has better images in their head than mine. Once again, a reminder, we'll be back in a couple of weeks' time on the 23rd of June. Again, same time at 7:30. Yeah, just thank you so much, guys, for providing such an amazing talk.
Well,
thanks. Bye-bye, everybody.
Hi, and again, it's good night for me. It's good night.
for them.
Take it easy.
Brilliant.
Have a good few weeks.
All right, guys. I hope you guys have a great evening. Please remember to like, subscribe, and share our YouTube channel so we can get more people down here